Okay, we're going to be learning about inequalities involving absolute value. If you can remember, I'll do this off on the side. We started with absolute value equations. Now we're going to do an absolute value inequalities. But with absolute value equations, we had something like x plus 3 is equal to 10. And we had to write our two cases. Case 1, where we remove the absolute value bars, we set it equal to a positive 10, and case 2, where we set it equal to negative 10. The key thing that, the big mistake that people are making is these absolute value bars have to be isolated prior to writing our two equations. And then we solve as normal, and we end up with x equals 7 and x equals negative 13. Okay, well let's look how that's different with inequalities. So, for example 1a, the absolute value of 3p minus 12 is less than 9. Well, I can tell you right now that those absolute value bars are isolated because there's nothing else on the left-hand side except the bars, what's in the bars. So now I'm going to write my two cases. 3p minus 12, oops, no bars there, without the bars. 3p minus 12 is less than 9. Then for case 2, we're going to flip 3p minus 12 stays the same. We're going to flip the inequality sign, and just as we did where we had the positive and negative case, we're now going to have the negative number as well, so negative 9. And then we solve as normal, so 3p is less than 21, divided by 3, divided by 3, p is less than 7. Okay, on the right-hand side, same thing, add 12 to both sides. 3p is greater than 3, divided by 3 on both sides, and p is greater than 1. Now we need to write our answer as an and or an or inequality. And so whenever we start with a less than sign, so this was a less than, I know that this is an and inequality. I actually call these less than as a way to remember that this is an and inequality. And that requires a compound inequality, which is going to be my smallest number that I got when I calculated, a less than symbol every time, x less than the big number, in this case p instead of the x. What that will look like is, of the two numbers I got, 7 and 1, I'd put my 1 first, less than, because it's smaller, p in this case, less than 7. Okay, example B, this is also a less than. So I know that this is an and inequality, and so I'm going to need a compound inequality at the end where I'm going to have less than x less than, so I'm going to be filling in my small number and my big number at the end. So let's solve these. So first case, we rewrite what's, I can't do that yet. I need to isolate my absolute value bars. So let's do that. So I would subtract 3 from both sides, and I have absolute value of x is less than 9. Now I can write my two inequalities, the given, which is x is less than 9, and the flip, where x is going to be greater than, and change the 9 to a negative 9. So you flip the inequality and change. It's kind of like the rule that some of you remember, keep, change, change. It's really the same thing that's happening here. I'm keeping what's on the left, changing the inequality sign, and changing the sign of the number. Okay, these are already solved for, so my small number is 9, less than x, less than the big number. And to graph these, what it ends up looking like is an intersection. I also call this an intersection. Some people make fun of me for that, but guess what? It sticks. And I have students that come back over the years and say, oh, that was an intersection. Okay, instead of an intersection. What that means is, if going back to example 1a, if p is greater than 1, that would look like this. And if p is less than 7, it would look like this, going this way. And so this is an intersection. All the numbers that occur between 1 and 7, not including 1 and 7. And for the graph, for example 1b, we have x is greater than negative 9, which is not here. So I'll just put it down here, negative 9, and less than, so greater than negative 9 would be going this way, and less than 9, open circle at 9, going this way, and so here's my intersection. We can still write these answers in set builder notation, so I'll do that underneath each answer in blue here. So for all values of p such that such that, back that up, 1 is less than p, which is less than 7. And the same thing here. For all values of x such that negative 9 is less than x is less than 9. Now the difference for these example 2 problems is that these are greater than symbols. When we have greater, I spell it as greater. It's not really how you spell greater, but because these are or inequalities. And I'll show you what that means. So we're gonna, our absolute values or signs are also already isolated, sorry. X minus 5 is greater than 4 is the first one then, and x minus 5, flip the inequality sign to less than, and change the 4 to negative 4. And now we can solve both of these. X is greater than 9. X is less than negative 4 plus 5 is 1. Okay, this is an or answer, so we're not going to write it as a compound inequality with the and. We're just going to place an or in between them. Let's see what it looks like. So x is greater than 9 would be going this way, and x is less than 1, both open circles still, going to the left. Okay, that's what an or graph would look like. We can write this in set builder notation as well. So for all values of x such that x is greater than 9 or x is less than 1. Okay, in example 2b, the absolute value bars are not isolated, so I'm going to add 3 to both sides first and just rewrite my original problem as x plus 2 absolute value is greater than or equal to 7 plus 3 is 10. And so now I'm going to write my two cases. X plus 2 is greater than or equal to 10, basically the original without the absolute value bars. And then my second one is going to be the flipped inequality sign and change the sign of the number. I'm going to solve both of these. Okay, the original inequality had a greater than sign. Greater, it's going to be an or. So I'm going to place an or in between. As set builder notation, I can write the all values of x such that x is less than or equal to negative 12 or x is greater than 8. And as on the graph it would look like x is greater than or equal to, sorry, missed that. Greater than or equal to. Okay, so greater than or equal to 8 would be a closed circle going to the right, and x is less than or equal to negative 12. I'll just place that over here. That's going to be a closed circle as well, going to the left. Okay, with absolute value inequality word problems. We start with the absolute value bars. We have an x. We take our constant amount of 4, place it here. We're going to put a subtraction sign, and then because it says within 0.25, within is like in between. That would be an intersection. If you picture it on a graph, it's going to be in between those amounts. So that would be less than or equal to 0.25. And we can find the range of depths by solving this now. So I'm going to write x minus 4 is less than or equal to 0.25. But then x minus 4, flip the inequality sign, and change the sign of the number to negative 0.25. Add 4 to both sides. X is less than or equal to 4.25. Add 4 to both sides here. And x is greater than or equal to 3.75. And since it was an and, a less than, I need my compound inequality with my small number being less than or equal to x, which is less than or equal to my big number, 4.25.